here we go. We have this netting that we're going to wrap around this plant, okay? So it's going to keep the soil and stuff in for right now, and then we can take it off in the future. So, if we make this into a shape by wrapping around something, what shape will it be? A cylinder. Now, would it be a bigger cylinder? It would have more volume if we were skinny and tall or short and fat. What would have more volume? Well, we got to figure out the volume of each. Now, to find the volume of the object, you find the area of the base, and it's like one sheet of paper, okay? And then you start stacking sheets of paper onto each other, and then it makes a volume, okay? Then it makes a volume. So, what's the area of the base here? What's the area of a circle? What's the formula for the area of a circle? It's right over there. Pi r squared. Now, you have a whole bunch of circles, and then if you stack them up, what's this distance along here called? The what? The height. So pi r squared h is going to be the volume of this. Okay? Now, if it's 60 inches across and we wrap it around, okay, the circumference of this is going to be 60, okay, because we're going to wrap it around. So we got to figure out what r is. Well, what's the formula for a circumference? Circumference equals 2 pi r. So 60 equals 2 pi r. And we got to get r alone. So we divide by 2 pi. Come on. It's not erasing. So we're going to divide by 2 pi. So it's going to be 60 divided by 2, or 30 over pi is the radius. So if we stick that into the formula, pi times 30 over pi squared times the height of 100. So this is pi times 900 over pi squared times 100. Well, this pi and one of these pi's cancel. So somebody in your calculator take 900 times 100 divided by pi. 900 divided by 100, or 900 times 100 divided by pi. What do you get? Okay. Now, when we do this one, if we lay it down, the circumference is 100 and the height is 60. Okay. If we lay it down, it's the other direction. So 100 equals 2 pi r. So if we divide by 2 pi here, 100 over 2 is 50 over pi. So the radius is 50 over pi. So pi times 50 over pi squared times h is 60. So pi times 2500 over pi squared times 60. Well, one of these pi's and one of these pi's cancel. So it's 2500 times 60 divided by pi. Do that now on your calculator. 2500 times 60 divided by pi. What do we get? Yep. Okay, so the short and fat gave you more volume than the tall and skinny. So if he wants to put as much volume as he can for his compost, then he should turn it to make the short fat way instead of the tall skinny way. Okay? Okay. Here's a stack of papers. Here's another stack of papers that's leaning. Okay? This is called a prism, a right prism. And this one, a leaning one, is called an oblique prism. All right, I have an example of that in here. So a right prism is straight up and down. Oblique prism is a leaning prism, kind of like the Leaning Tower of Pisa. Okay? Now, if I had a stack of papers and I slid them just like that, would the volume be any different in this stack of papers than this stack of papers? No. So a leaning object will have the same volume as a straight up and down object. Okay? A leaning object will have the same volume as a straight up and down object. And that's called Cavalari's principle, which is right here. Cavalari's principle states that if two three-dimensional figures have the same height and the same cross-sectional area at every level, then they have the same volume. So, these two jars are going to have the same volume. Okay? They're going to have the same volume. So, the height of each of these is 25. The diameter of each of these is 20. So, this one, or they're each going to have the exact same volume. So, the volume is the area of the base times the height. When you have a prism, it's the area of the base times the height. When you have a cylinder, it's the area of the base times the height. But what we do with the cylinder is we know the area of the base is going to be pi r squared. So we just say pi r squared h. For a prism, it could be a triangular prism, so we can't just say, well, it's length times width times height. Okay? Because it could be a triangle as a base, just like this one. Okay? This guy makes this triangular shaped firewood holder. Okay? So, will this be enough to store 20 cubic feet of firewood? Well, let's find the volume of it. The volume is the area of the base times the height. Now, the area of the base, remember when we were doing prisms, if it was laying down, what's the base? If it's laying down like this, what's the base of this? The triangle. You have to tip it up like this to think of it as the base being on the bottom. Okay? So if it's laying down, the bottom is not the base, the triangle's the base. So the triangle's the base. So if we laid it down, it would look like that. So you have to find the area of the base, the area of the triangle. Well, the area of a triangle is 1/2 the length of the base times the height of the base, and then it's times the height of the object, the distance in between the two bases. Okay, so it's 1/2 of 6 times 4, that's the area of the triangle, and then times 2, the distance in between the two bases. So 1/2 of 6 is 3, 3 times 4 is 12, 12 times 2 is 24 feet cubed. Is there enough room in that to hold his firewood? Yes, there is, because he needed to hold 20 cubic feet. Marta is repurposing a sandbox as a garden, and she's buying soil from her school's fundraiser. Estimate the number of bags she needs to buy. This is like real-world application. Okay? How much do you need to buy without overbuying and making 2 trips to the store? Okay? So, we got to figure out how many square feet, or in this case, how many square inches this is. Because if this is measured in inches, feet, and feet, generally you go down to the smaller denomination to figure it out. So 4 feet is how many inches? 4 feet is how many inches? Well, in each foot there are how many inches? 12. So 4 times 12, there's 48 inches and 48 inches. So you take 48 inches times 48 inches, the area of the base, times the height, 10 inches. Somebody with a calculator, figure that out for me, please. 48 times 48 times 10. 23,040 inches cubed. Now, a bag of soil is 10 inches by 18 inches by 5 inches. So let's take 10 times 18 times 5. Length times width times height. Okay? And what's 10 times 18 times 5? 300. 900. Okay? So, if that's 900, if we take this 23,040 cubic inches divided by 900 cubic inches per bag, we get the number of bags. So it's 23,040 divided by 900 to the nearest tenth. 25.6. So she needs 25.6 bags. How many bags should she buy? 25 or 26? 26. Okay. What if it was 25.1? How many bags should she buy? Still 26. Why? Because 25 wouldn't be enough. Okay. She needs one more. So she needs 26 bags. Catherine is using cans of juice to fill a cylindrical pitcher that's 11 inches tall and has a radius of 4 inches. This is 4, this is 11. Each can of juice is 6 inches tall with a radius of 2. How many cans of this fit into this? Well, this is pi r squared h. So pi times 2 squared times 6. Or this is 2 squared is 4 times 6 is 24. So this is 24 pi. Over here, pi r squared h is pi times 4 squared times 11. 4 squared is 16. 16 times 11 is 176. So what's 176 pi divided by 24 pi? Well, the pi's cancel, so we don't even have to worry about that. What's 176 divided by 24? 7.3. So, if she gets 8 cans, it'll overflow. Okay? So, she should just buy 7 cans of juice. Kimberly is putting laundry detergent into this canister from the small to the big. How many smalls will fit into the big? Well, when it's a box, it's super easy to find the volume. Volume is length times width times height. What's 12 times 9 times 14? Over here, the volume is the length times the width times the height. So the volume is 264. So if we take 1512 divided by 264, what do we get? 5.7. So 5.7 fit in there. Benito has 15 neon tetras in his aquarium. Each neon tetra requires at least 2 gallons of water. What's the maximum number of neon tetras Benito can have in his aquarium? Okay. So 1 gallon equals 231 cubic inches. We got to figure out the number of cubic inches in this aquarium. If the diameter is 16, then what's the radius? 8. So the volume is pi r squared h. So the volume is pi times 8 squared times 32. Now you're going to push the pi button on this one because this doesn't have pi involved. Okay, so we'll round it. So take pi times 8 times 8 times 32. It's going to be a big number. How big is it? A few thousand, right? Pi times 8 times 8 times 32. What do you get, Keisha?
6,434.
Okay. If we divide it by 231 cubic inches per gallon, then we find the number of gallons because this is cubic inches. How many gallons do we have? 27.9? Okay. So basically, there's 28 gallons of water. Each neon tetra needs 2 gallons of water. Is that tank big enough for 15 of them? No, not quite. Big enough for 14. Actually, really close to big enough for 14. But the 15, it is not. Okay? Are we good with this? Have we done enough now? All right. So, volume equals area of the base times the height. When it's a rectangular base, you just take all three numbers times each other. If it's a triangular base, you have to take 1/2 of this times the height. Okay? And Cavalari's principle, if it's leaning, it's the same volume as if it's straight up and down. Okay? So I will put out your assignment. You have 40 minutes to work. So let's get that done. Those of you with makeup work to do, you can maybe get some of your makeup work done.